we have, say, author and tweet goes to the tweet data. Then we'll have the followers, and here all the data we're actually going to need is stored in the key. So it's who's followed and who's the follower. And then we'll have a feed table, which has, for a given follower, it has the tweet, all the tweets in order. Now, it's important here that the IDs for the timestamp for the tweets are ordered so that when we request them, we get them in the correct order. So that's basically the timestamp on the tweet. So we do this in two parts of this in the slides. So we use a trigger. So we have a trigger. So whenever something changes on the tweets DB, we'll get the key, which was the we'll get the key, and then asynchronously we'll get the tweet back out of the database. We'll parse it, and then we'll do a read stream on from the followers, and we'll get all of the authors, all of the tweets by that author. Sorry, we'll get all of the followers for that author. We're all followed by the author. And there's a little trick here, where the start and the end. So the end is just the same thing as the start, plus the tilde. Now this is important because tilde is the last printable ASCII character. So if you put that, use that at the end of the if you use this as the end of at the end here, then you'll get everything that starts from the author's name until the end of the name, including any suffixes that we may have stuff on that. Then the second part is we do this read stream. First, from the previous slide. For all of the followers, we're going to copy that tweet, the original tweet, to their feed. So this will write the tweet to all of your followers, and when they want to see their tweets, they just need to do one range request, and it'll be really fast. And just all of the followers are collected, and then that's saved in the batch. And then we call done, and if the process fails in this intermediate period, then the whole thing will just run again, but it will just overwrite the previous tweets, so it will still just look exactly the same. So in this previous slide, it's saved into the same database. But in this case, these could all be separate databases running on separate machines. It would still work. It would still look exactly the same, but you could scale it out incrementally wherever you go up. So there's also other places stuff. So replication, master slave replication. So we use the level master module. We attach it to a database. This will create a new subdatabase that comes with that. You can pass in the prefix name as well. And then we can create a stream of that and stream it to a slave database. And whenever you insert into the master database, it will copy that insert into the slave database. And if the network goes down, when it comes back up, it will efficiently figure out where it was up to and then read the stuff that's changed since then. So this isn't a batch job, this is like rapidly, like soft real time. So pretty fast, pretty soon after it happens. Not immediately, but soon. And so this is good for two things really. You could have a single master where all the transactions go through in order, and then it's copied out to a whole bunch of slaves that you can load balance the reads across. So if you've got tons and tons of reads, you can do it like that. Or another thing useful for is you have a whole bunch of different distributed masters, and then say you're getting real-time data into there that's like from different locations, and then you aggregate that data on each master, and then you feed the aggregation back into a single master where you do a final aggregation to find out what's been happening in the entire world. And this would work in real time as well. Just with the regular, just by replicating the output of the mapreduce into another database and doing another mapreduce on it. And because also, like other databases, like you can't do as for research, you can't do a second mapreduce on a first mapreduce in CouchDB or Mongo. But the way that LevelDb is just modules and stuff, you can do pretty much whatever you want. So what about master replication? This is where the difference between master slave and master is that both databases are accepting writes. So you can have, so it basically looks the same, it's just we create streams that connect to each other. The warning is that it won't work reliably if you overwrite the same piece of data. Every database has to be intent, but it would work. It would just work with like the Twitter example basically, because we never overwrite old data on Twitter. Even a delete is like a new tweet basically. It's like basically an empty tweet that says this old tweet was deleted. And when that comes in, you want to delete that. Oh, it just came out. I only started writing that yesterday, and it's not actually finished yet. The previous slide is what it will look like next week. This is something I wrote a few weeks ago, so this is real. So doing full text search on LevelDb with an inverted index, you basically, whenever a document comes in as a value, you like split it into words or something. Pass it to index, and then that will put it all in the, so each word will point back to the document, and then you pass in a stub function that for a query, it gives you the doc, and then you can return something that will appear in like a short, a short blurb or something that when you type the search, it returns you, and it matches, you can put in something that will find the bits where it matches and highlight those and that sort of stuff. And that's generated when you do the query. And this is how you query it. You just pass in, create a query stream, pass in your search terms, and it gives you back a stream of matches. A whole bunch of other crazy stuff as well. Level store is basically, I think Julian Gruber's has started recently. It's for, it basically gives you a file system like API where you can store files into LevelDb. Apparently it will be faster than...
Not in all cases.
No, sometimes it's faster than using just the file system directly. MapMerge is a variety of, as a variation on a mapreduce, where the map is periodically as batch, and it's much simpler and more lightweight than a full-blown mapreduce. Level match is a thing for doing SQL style queries that another Kiwi who's not here right now wrote. Interesting thing here. So LevelDb. So LevelDb is the backend for IndexedDB in Chrome. Now, IndexedDB is known to have quite a horrible API. So we polyfilled it back to the LevelDb API. So it's I think polyfilling is kind of the way of JavaScript. You get given this piece of shit. You get given these piece of shit APIs that basically work, and then community iterates on these in the Emacs philosophy. Eventually comes up with something much better. Like you have the DOM, and then we get jQuery, which is much better. And even Node.js could be considered to be a polyfill for the operating system. So level scalable up in RemSDB, some other stuff we're working on. This is for real-time interactive data. Notice the pizza's arrived, so I don't want to keep you guys. But you should check that stuff out too. Loads more up here.
Yeah, it's basically for everybody a copy of
Well, I think if someone's got 1 million followers, just like randomly don't copy some of them and not remember.
Just like Facebook.
Same for people who follow 50,000 people.
Yeah.
It doesn't have to be creative anymore. It's like you're abusing the service.
You can't possibly see that many tweets.
No.
For risk of making a fool of myself, because I don't understand much of this.
Mm.
You actually do with the database what we used to do with queues in the 90s.
Yes.
Okay.
Mm-hmm.
I like, kind of being able to have something nice and basic and bolt onto it. Are you taking any kind of performance hit with some of the stuff not being natively supported by the database?
It still runs subjectively pretty fast. I know I haven't actually benchmarked it because I'm waiting for someone who actually has a problem, not before, or there's like a benchmark or something like that, where I know whether I'm succeeding or not, rather than fixing it up. I haven't personally optimized anything, but I haven't done anything like dramatically stupid. Like the biggest performance problems are usually caused by bad architecture, rather than just like a few lines of code and that sort of stuff. Yeah.
If you're using, like Dominic does, if you're just using strings in your database and you're doing the JSON encoding and decoding at the endpoint, then what you're really just doing is adding functions to functions, and V8 is really good at optimizing away small functions. It'll just inline them all. So your performance should be pretty good even when you've got these multiple levels of nesting. As long as you're not doing extra I/O, which is going to cost you anyway, then it should be pretty good. And Julian has been building some really cool benchmark suites for LevelDb versus some other alternatives. So as we go on building these different modules and these different ways of putting them together, we should be able to compare the various solutions that are possible.
So I just want to pick up on something that Rod mentioned in his talk, which is that deep underneath the covers, because you're using threads, there is a slight non-determinism in the operations. But is that theoretical rather than practical? Have you ever seen it?
Yeah, no, I've tested that, and I've tried doing like a huge ton of like deletes and puts.
Yeah.
At the same time, say doing one and then synchronous doing the other one after, and then seeing which one returned first, and then checking if it actually had deleted it,
Did it actually work?
written it or deleted it, and I found yes, it is indeterminate. So, but if you wait for the callback to return before you do the next thing, you're
Okay, yeah. So if you follow
Yeah.
kind of standard Node.js code patterns, you're fine.
Yeah.
Okay.
It's also impacted by the size of data as well. So,
Yeah,
so if you've got different size data, then it takes longer to copy.
Because the next operation could be in a different thread.
Yeah.
Yeah.
But I mean, this is accidental, right? Because it might be fixed down the road by your implementation.
Yes. But it's probably not. If you rewrote LevelDb to use only to be single threaded and to use LibDB, then it would be fine.
I think that'll fix it, yeah.
Oh, except they use a thread pool with the file system.
Yeah, but it's only controlling that, so you're controlling the ordering. There is, we do have a project on the way to rewrite this all in JavaScript, as we do with everything.
But if you want operations to happen in order, you are going to wait for the callback anyway.
You're going to wait for the
because
callback.
you want to catch errors.
This only affects you if you don't wait for callbacks.
Yeah.
So in practical terms, it's not an issue.
And it's classical node anyway.
And in any case where you want for multiple things to go on at once, if you use a batch, then that will either
That's
go or
guaranteed.
not. And that is like the key. That's the key for like doing anything. So like that's how the trigger works. Is when something is inserted into one section of the database, it hooks into that and writes and adds to the batch that also insert like a job into a to-do list basically. And then when that's saved completely, it'll start doing the job. But if it crashes while it's doing the job, then when it comes back up, it will see that there's an unfinished
It'll
job in the job section, and then start doing it again. But if it crashed before it had saved the thing, then the callback would never return, or if there was an error returning, then you're in the same place as you were, where it's either like the job, the data is not saved and the job isn't done, or the job data is saved and the job is eventually done. Thank you very much.